All right, everybody, welcome to, if not your last session, maybe close to your last session. Everybody, my name is Jeff DeVerter, and for Annika, a rack-based company, I am the Chief Technology Evangelist, which means I get to work inside of our office of the CTO, I get to help on our technology direction, and then I get to help tell that story to the world, whether those are rack-based customers or anybody who'll sit and listen. So, run away if I come close. You'll hear a lot of it. So welcome to this event, and I'm really excited for this one because it's all about telling a story. It's telling a story about a company that went through a really interesting transformation. Now I have in my cup a delicious glass of water, and it's something, I love the fact that I meant to bring my water bottle because I love that AWS did the whole event with the water bottle and every drink bringing value and helping bring clean water, but it's one of those things that I don't think an awful lot about, unless you work for a company called Innovise. Now, Innovise is on a mission, and you're going to learn all about that mission today, and how technology, specifically AWS technology, has helped on that journey. All right, so ready, set, innovate, building the future. Let me introduce you. We're going to go through let's not go through the introductions. Let's just do this show. But I want to introduce you to my partners on stage here. Rick Gruenhagen. Rick, why don't you introduce yourself?
Yeah, I'm Rick Gruenhagen. I'm the CTO at Innovise.
Excellent. And we're also joined by Boaz Brender. Boaz?
Hey, I'm the head of Innovise SaaS Engineering AI Architecture.
And these are just the people that we need for this event, because what we're going to talk about is what the challenge that exists in the world with water today, the business mission that Innovise is on, and how AWS Technologies has helped them move from an antiquated technology environment that was literally holding the company back to a point of extreme innovation, as you'll hear about a little bit later, that has been unlocked through the power of technology and the impact then, of course, that's having on the world. So, Rick, why don't you tell us a little bit about Innovise? I'll give you that.
Yeah. So Innovise for more than the last 3 decades, actually, has been the global leader in software and analytics for the water industry. We help over 6,000 utilities in 60 countries to plan, design, analyze, operate, and maintain water infrastructure. In March of last year, we were acquired by Autodesk, so we are an Autodesk company. And this just represents Autodesk's commitment to building a more sustainable world through end-to-end infrastructure.
Yeah, okay. Click away, take it. Tell us about the crisis that exists.
All right, so yeah, let's actually first talk about water and talk about what the problem statement is. So first of all, at Innovise, we believe that water is life. It's essential for socioeconomic development, sustainability, and ecological safety for all life on the planet. And yet, less than 1% of that water is accessible fresh water to fuel and feed not only the 7 billion people on the planet, but every other living thing on the planet. Water scarcity affects 1 in 10 on the planet, and poor water management contributes to this scarcity as well as unhealthy water conditions. So, in fact, about 2 billion people live without access to adequate sanitation, and every day 800 children die of chronic diarrhea caused by contaminated water and poor sanitation. In addition to that, Jeff, extreme climate conditions also contribute to drought and severe storms, creating floods that harm people and property. So on top of these natural and man-made conditions, our aging infrastructure also impacts both the availability and safety of water resources. And we'll talk about that a little bit here too. Okay, so in the US, where there are pipes in use today that were laid more than 100 years ago, a water main breaks about every 2 minutes. And leaky pipes lose about 4.6 billion gallons of drinking water every day. That adds up to about 1.7 trillion gallons of water a year, and you can see the financial impact of that here on the screen. And of course, it's not just a US problem. In Japan, the cost to rehabilitate aging assets is estimated to be about 59 trillion yen, which equates to about 500 billion US dollars. So the health risks of not maintaining our infrastructure are equally high, with incidents of fatal poisoning like we saw in Flint, Michigan many years ago from lead pipes, or sewage overflows. An example of that is in 2019, failing sewage systems in England caused more than 200,000 instances of untreated sewage release, equal to 1.5 million hours of sewage discharge. So, despite the criticality of these issues, it's not just expensive to maintain and upgrade this infrastructure, it takes many, many years.
It's not a fast process.
Not a fast process, no. And the opportunity, as in every other industry, is to leverage the power of data and digital transformation to optimize that life cycle for water.
Well, that's an interesting thing to think about as well, because we come to these events like here at AWS reInvent, and we learn about technology. I was fascinated with the keynote this morning from Dr. Werner Vogel's presentation, but it's deep in the tech. But then we start here and we learn about the challenge that exists in water. And it's not just on, I held up my cup before, it's not just on the clean drinking water side, it's on the other side, the sewage side as well. I was in a webinar just earlier this week, and that is an environment that not a lot of people think about or we all take for granted, but is one of those areas from a cybersecurity point of view. If that became unavailable, it's a really bad many days. Life changes dramatically when the sewers don't work. And that can happen either, like I mentioned, either through cybersecurity, or it could happen through aging infrastructure and just poor planning. And like you said, that is where data plays into it, and it's where digital transformation and the real world hit an amazing intersect point. So why don't you take us through a little bit of that, Rick?
Sure. Yeah, thanks, Jeff. In addition to that, the utilities are really struggling with consumption outpacing the demand for those water resources. The rising costs of energy and the chemicals needed to treat that water is also problematic. And there's ever increasing regulation on the utilities that they have to comply with severe penalties if they don't. And in the US, we see many cities such as Houston with consent decrees that they have to respond to and comply with from the EPA. Large utilities generally can afford complex systems to manage their water, but the opportunity here is for smaller utilities, which often don't have the funds to do that. And really, what's needed is democratization of smart water management. They need more cost-effective ways to build more resilient systems, to better optimize operational performance of those systems, to be better able to predict and prepare for future scenarios. So we talked about how many, that it can take years to upgrade this infrastructure. Yeah. If we can actually predict those things, then we can plan for them, and then we can be ahead of that.
That's right. To the keynote this morning, simulation. Simulation
is key, and we'll talk about simulation here coming up, and what we do with respect to hydraulic simulation. All right, and of course, a big focus of ours is economic and environmental sustainability. So these goals are largely enabled by more timely and accessible data insights, which are not only used to run operations, but are used to improve the planning, design, and construction of future water networks and structures. And so that's what, hence you can see why Autodesk is interested in Innovise, because they're all about building and that sustainable infrastructure in buildings, and we tie well into that. Okay.
So how do you do it?
That's right. So innovate solutions cover the entire water life cycle from rainfall to ocean. We ensure the delivery, or we have tools that help to ensure the delivery of clean drinking water, safe sewerage, protection from floods, asset maintenance, and risk mitigation and optimal water infrastructure performance. So how we do that is we build a suite of design and hydraulic simulation. There's simulation, again, tools for water systems. Asset management tools to help to assess risk in the form of prediction of the likelihood of failure, the assessment of the cost of that failure, helping the utilities to actually build the financial plan, the action plan that they need to upgrade that aging infrastructure. And operational monitoring and predictive analytics using real-time data, which we'll talk in detail about how we do that, and along with artificial intelligence to deliver those predictive insights and guidance to the operators.
Well, they say a picture's worth 1,000 words.
Being on water is my happy place. Sailing, paddleboarding, down at the beach, down by a river, near a canal. I've always come back to the water. Is really, really important to me. So when I go and visit the canals, there's some elements of it where you're just completely in awe of what you've got. The Forth and Clyde Canal was the world's first sea-to-sea canal. So you look at the vision of the people who were creating this. No roads, no railway lines. So when it opened in 1790, it was almost the internet of its time. It was high-speed travel. It underpinned the development of the city of Glasgow. But by the 1960s, the canals effectively were considered to be redundant and of no purpose for anyone. They became contaminated, they became abused, they became places that people considered to be unsafe.
You know, the canal was dirty and covered in the algae and, you know, wasn't somewhere safe.
I remember talking to a friend and she was saying that her cooker had broke and she had no option but to chuck it in the canal, as if that was what you'd done. It was just a resting place for junk.
Ensuring that they have a purpose in the 21st century is key. They have to be valued by society, by people, by communities. Otherwise, people turn their backs on them. So the aim of the project, the Smart Canal, is to repurpose the canals and make them support 21st century society.
Autodesk is a company that provides technology software to a whole range of industries. I think what makes the Smart Canal smart is that it's using a whole range of technology that's put in place to monitor it on an hourly basis. So it's combining the real-time data as well as forecast data to be able to give that view of what's happening now, but what will happen in the future too.
One of the most critical components of the entire system is the software that's been provided and created by Autodesk that's allowed us to create the digital twin. So we have a real canal that's 230 years old, represented in a digital twin model.
Digital twin software is a digital replica of the real world. The digital twin uses the live data from sensors in the canal as well as forecast data to see when there's going to be flooding. It then is able to operate the sluice gates.
So along the canal we've built 3 sluice gates, and so we can open those up and the water then leaves the canal. So using technology to make the canal be ready for the rainfall, taking the water out of the canal before it rains creates the capacity. The approach of dynamically managing a canal for surface water management, it's the first time anybody's done this in Europe. Accessing the data remotely is brilliant, especially, as an engineer, being able to look at a digital representation of the canal, understand exactly what's going on at a certain point in time is really invaluable to us. Without that software, the project just couldn't exist. We've changed the canal, repurposed it to support the development and regeneration of North Glasgow.
Prior to the project, if it had rained, the water would have had nowhere to go and the area would have flooded. Now, because of the Smart Canal, that's able to drain efficiently to utilise the storage that's created in the canal. So this has meant that the area is now free from flood risk.
The scheme has unlocked the potential of all that development of 3,000 new homes by utilising the canal and repurposing it. Because we've not had to go and construct the alternative traditional engineered drainage solution, we've effectively saved 5,000 tonnes of capital carbon. Or even better, when we start seeing the development of areas like the Clay Pits Nature Reserve, where the local community are taking ownership of it.
Right in the heart of Glasgow, 5 minutes to the city centre, but when you're here, you know, you really could be anywhere.
As a volunteer at the Clay Pits, we do litter picking, which is more of a walk sometimes because, you know, we're very enthusiastic picker-uppers. The whole thing makes me feel proud. It makes me feel as if now I'm part of a community.
People are proud of what the place and the area, and so we're thankful for that.
For me, I only actually have to walk along the canal and go up to where the development's taking place and see the houses being built. And there are people now living in those houses, so the community is starting to grow as a result of this project.
I think it's a great thing to be a part of, and we hope that because of that and the enthusiasm and the kind of interest that it's got, that it will help more people see how this can be applicable to them wherever they are in the world.
The climate is changing, and the world has got some big problems coming at us, and I think everybody's starting to really wake up and realise that. And this project demonstrates that the solutions are out there. The technologies are there. It's almost like we've developed a proof of concept. We've justified the canal's existence and its purpose in the 21st century.
So you start to think of water as being somewhere that you can enjoy.
It's a haven for wildlife, a haven for people.
And there it is. Isn't it interesting when you take a situation, whatever it might be, and in this case it was the canals in Glasgow, and think about what that desired outcome might be, and then see how technology can play into it. And that's, in this case, one segment of the water life cycle. So, Rick, why don't you take us through where your software suite fits into all of this and what those solutions are?
Sure. Thanks, Jeff. And you can see in this video that it's about more than just clean water. I mean, the reason we all get up and do this every day is because it has impacts beyond that. You can see this is now a very valuable, it's been converted literally from a garbage dump into a very valuable community resource, natural resource. You heard them talking about opening up the ability to build 3,000 homes on the canals. So this is just one effort, one community that we work with. So what I wanted to do was actually start just, you heard the term in there, digital twins. So let's talk about digital twins.
Yeah, let's define that.
And define what that means. We'll go into in a little bit of detail. I want to first tell you a little bit about our journey in building our digital twin platform that we call Info360, that's built on AWS. That journey started, just about 2.5 years ago, when we, in I think May of 2020, we wrote the first line of code. Yeah. And in February of 2021, we released an application called Info360 Insight, which actually gives operators of distribution, water distribution networks, which actually take the water out to your home, and wastewater and sewer collection networks, which actually process all of that wastewater, right? Visibility into how their assets in their network are performing in real time. And it gives them the ability to actually address incidents in that infrastructure. So we talked about those water main breaks. Here's a solution to alert those utilities operators to when those are happening and allow them to simulate different outcomes for responding to those incidents. About 6 months later, actually at Autodesk University in 2021, we released an application called Info360 Asset. So this just shows the power of the platform and of building these services composed of managed services on AWS. Info360 Asset really is about now planning, looking ahead, right? We built an asset model in Info360 We leverage computational algorithms and ML to predict the likelihood of failure of those assets in the network, to actually assess the cost, which really equates to the risk of the failures, and allow those communities or those utilities to create an operating plan for upgrading and enhancing those assets. We've since extended that functionality to the treatment plant, and at Autodesk University again this year, we released Info360 Plant. And we're relentlessly continuing to drive forward that platform effort, now working on incorporating, adding real-time and ML capability to our core hydraulic simulation products that you see under water distribution, sewer, and drainage. Okay. So what is a digital twin? And we extended that a little bit further to call it a dynamic digital twin, because what we see in sort of the IoT industry at large, where you're modeling physical systems with a digital representation, that a lot of them are static, so it's a point-in-time representation. We actually take that a little bit farther by augmenting that with real-time data. So the models are continuously updated. The state of the infrastructure is continuously reported and updated, and so you continuously know the state of that infrastructure. So how that works is that we build an asset model. We gather all of that asset information in the cloud. We connect that real-time telemetry in, and we then decorate those assets with all of that historical and real-time information. We use that to actually discover new insights, and then we can also use our ML capability and our computational simulation capability to predict future performance of those assets, and of course recommend what actions should be taken. Okay. Here's kind of a architecture view of Info360. We're going to go into a lot more detail on the next slide, so I won't belabor this too long. But the point of this slide is just to show that we built a layered architecture here. All of our applications are built on top of services that are either water-specific domain services, they're industrial IoT-specific services that you might find typically in any industrial IoT platform, or there are other kind of basic infrastructure pieces that are provided by AWS, such as AWS IoT, the AWS IoT platform, or key third-party partners of ours like Snowflake and MongoDB. And with that, I'm going to hand it off actually to our chief architect and the head of our SaaS and AI team, Boaz, to go into more detail on that. So Boaz,
take it away. Thank you, Rick and Jeff. So with that, Rick mentioned a number of things that are really important. So we wanted to make sure that we developed our SaaS solution very fast, very scalable, and make sure that we provide value to our customers, which is really good, and at the time that they needed. So we had to think about a really good development approach to how we develop. So the first thing was to choose a good provider for our cloud services, and that, of course, came down to be AWS. There was no real question there. But at a higher level, we wanted to think about how we build and how our teams really approach the development of these services. So a number of things are key factors when we look at how we develop. So the first thing is minimize undifferentiated heavy lifting. Let AWS do the hard work for us. We look at services within AWS and we try as much as possible to leverage those who are more serverless and managed solutions. Starting from compute, the first thing is compute. We start always trying to make sure that we can develop something on Lambdas. The reason why we pick Lambdas for our compute as the first option is because those are simple. You just develop your code, push that through your life cycle of development, QA, and production, and they just run. They can scale to the level that you need. They can scale down, so you don't need to pay for unused scale. And there is no need to maintain anything in terms of patching, updates, and maintenance. It just works. Now, Lambdas do not work for everything that we need. Sometimes we need to go one level lower. And when we do that, we go to the next best option, in our opinion, which is containers. But then again, running those containers on a serverless solution, which is AWS Fargate. Again, we don't need to manage any kind of infrastructure. We don't need to update and patch and kind of think through how we scale things. It just works. Now, then again, containers do have a little bit more involvement from our side. Sometimes we need to patch them and update the base images, but it's much easier than to manage a full cluster of servers and so forth. Now, at times, I have to say, even containers are not enough, and we need to go to that lower layer of abstraction. And at times, and in very rare cases, we had to go all the way to build and run something on EC2. We have one of those to date, where we had a legacy application that's been built for a very long time ago on Windows, and we just picked, we're going to run this on an EC2 Windows server, and it's been there and it's been working fine. That said, in the near future, we are breaking it down to Lambdas and containers, and very soon, even that will go one level higher in that abstraction, leaving us with less undifferentiated heavy lifting. Another factor that we wanted to make sure happens is that we wanted our teams to be very much independent. We wanted the teams to be able to define what they needed to do, to come up with a product or a feature very quickly without needing to talk or interact with other teams too much. And for that, we chose event-driven architecture. When you choose an event-driven architecture, then teams do not need to coordinate too much. They interact through messages during application runs, and that's how we see a lot of gain in terms of speed. Now, another thing that Rick mentioned is that a lot of our applications really need that real-time data. How do you get real-time data? And when I talk about real-time data, I talk about sensor data from our customers' sensors. So think about flow meters, think about pump temperature, think about reservoir levels, and all of those things that utilities and plants have in their edge systems. Usually what happens is that those edge sensors bring the data to a local data center, and it's usually very much closed off, and it's almost impossible to get it out because it needs to be very secured. So how do we do that? How do we take that enormous amount of data that is near real time, bring that to the cloud, still in near real time, for our customers to be able to get different types of views and decisions within our applications? And for that, we leverage the AWS IoT family. Starting with the AWS IoT Greengrass, we built an ingester or a component on top of AWS Greengrass, wrapped around a simple set of installers for Windows and Linux. Our customers are able to go to our dashboard, download that installer, simply install that on a virtual machine within their data center, and then securely have that data start to flow to the cloud. We do that through, again, managed services, either IoT Core or Kinesis Firehose, which pushes the data to the first point in AWS, which is S3. From there, the data is ingested into either MongoDB or Snowflake to be leveraged by the various products that we have. Now in the front end, going all the way to the front end, we again look into serverless solutions. And this is kind of becoming a standard de facto standard for most customers, I hope, within AWS, is to run your web front end on S3 web services and then flow that front end through CloudFront. And that is what allowed us to have very little friction between teams, very little overhead for DevOps, and ability to run very quickly to build our software. And that's what allowing us to, about every 6 months, to deliver products from start to finish. Now, I'll talk about one more thing. I know that you guys are interested in AI and what we do there. So we have a number of different features and products that use AI. And I'm not going to go into all of them. I'm going to go into something that is very interesting, very unique. And that is a solution to optimize energy consumption and chemical dosing for water and wastewater treatment plants. So these plants use a lot of energy to treat water. They use a lot of chemicals to treat the water again. When they finish cleaning these waters, they have to make sure that the water itself is clean to a level that is defined by regulation. But at the same time, they do want to make sure that they minimize the usage of energy and chemicals to save on cost, to be more environmentally friendly. So how do we do that? How do we help our customers get the best recipe to operate their plant on a day-to-day? So we use some optimization mechanism. So the first thing is, how do we provide that optimal operational recipe? To do that, we first need to understand how the plant operates and how the different pieces of the plant interact with each other when various actions are performed. So we really need to understand the various intricate correlations between the different systems, pumps, reservoirs, inlets, outlets, chemicals, and so forth. So the way we do that is we have our data scientists pull data from the various telemetry sources that plants have. That, as I mentioned before, comes through from our ingestion pipeline all the way to AWS. It's available for our data scientists to create models. Then our data scientists create models for the various pieces of that wastewater or water treatment plant. The way that they do that is leverage some of the AWS capabilities, which I'll talk in the next couple of sentences. And once we have that set of models, we are able to constantly run sophisticated optimization algorithms to find the best optimal way, or to find the optimal way to operate the plant to, again, minimize those energy and chemicals used in the plant. So, seems complicated. I have to say it is. But we are simplifying that as much as possible with some of the AWS tool sets. And most of those are the SageMaker tool set. So let's start with the first one, building models. Some of our customers have large plants, and sometimes they need north of 100 models per site. We need to create an effective way for our data scientists to create so many models. So we start with the basics for data scientists, which is their notebooks. So we use SageMaker Studio, which has been a great solution for us to have our data scientists work from within. It has a lot of tools. It is very simple. It's cost effective, and it just works in a stable manner. Then, how do we create a situation where our data scientists can run a lot of experiments so they don't need to manually figure out which algorithm and which hyperparameter fits for each model? We have a lot of those. We have a lot of algorithms that we've created over the years. Some of them are public, some of them are proprietary. Every piece of equipment may be suited better to a different algorithm or a hyperparameter set. And for that, we highly leverage SageMaker Automated Model Tuner, which allows us to run lots of experiments very quickly, come up with a correct algorithm that is best suited for that, and have the correct and best hyperparameters. Then going to the next step, how do we take these models, and sometimes those are more than 100 models per site, and move them from the development environment where data scientists work throughout QA, where we can test those solutions, to production and make sure that nothing gets messed up during that path. And for that, we use SageMaker pipelines, because that allows us to take accurate models with their parameters and push them through that cycle of development and production. And last thing that I wanted to mention is how we do that in a cost-effective way. Because the naive way would be to take each model and run that on its own inference, on its own inference instance, and then run optimization algorithm against those inferences. That would be a naive solution that will probably be very expensive, because as I mentioned, each customer may, in some cases, have more than 100 models. So the way that we solved that was through SageMaker multi-model endpoints. We take a very large, and it is very large, instance of SageMaker and load all of these models to that SageMaker multi-model endpoint. And the way it works is that we've got one of those that can serve all of these requests. So in terms of numbers, we have, for some of our customers, more than 100 nodes that we need to simulate. So more than 100 models. We need to run these simulations about a few dozen times in every hour. So these are thousands of simulations across all of our customers, run by very few multi-model endpoints. And that's how we are able to deliver our customers a solution that tells them every couple of hours, this is what you need to do in order to minimize your energy consumption and chemical dosing, while still maintaining the water quality you're required to maintain.
So super interesting, Boaz. One thing that I keep thinking about when we talk about this is you guys get to see, well, I mentioned before in my role, I get to spend a lot of time with customers. I get to spend a lot of time with just all sorts of folks and tell them about what the technology could do for them. And that's where those conversations tend to always happen. What's exciting about this is you're hearing about what technology has done and continues to do in an environment where, you know, as long as we have had pipes that transported water from one place to another, or canals that took water from one place to another, the need existed for this type of a solution. Now, the company, multi-decade-old company, 30-some years, memory serves, they've been doing this with technology, but it's been in the recent several years that this transformation into utilizing the tools available from AWS has come into existence.
Yeah. So that's an important point. So you can't do all of this without the right people, of course. And 3 years ago, we had the very, very best engineers. If you were looking for people who knew how to model water flows over land, through these collection systems, in treatment plants, out through the distribution systems. And we absolutely had the best products in the market, on the desktop, on-prem.
Yeah.
But we did not have the expertise to build that in the cloud. And so, you know, I have partnered with Annika in the past, but we brought in Annika because we knew they would be a good partner in this. And Annika actually helped us to build the expertise. They brought in the expertise initially, helped us to build the team, and that relationship has transitioned over time, right?
It has, it evolves, yeah.
Into one where we now work side by side, and they augment our team. We've actually worked very hard at bringing along those engineers that were with the company when I joined the company, and we have, I think, about 15 people now who have achieved AWS certifications that actually came from the original team.
Nice.
Which is a huge accomplishment in an engineering team of 100 people. to consider that 15% of them are now AWS certified, and some of them have advanced certifications. And it all started with our relationship with Annika.
Yeah. And that's the thing. I mean, we talk about all these levels of the art of the possible through the technologies that's there, but the hardest part of it is how do you take the organization along on the journey? It's not a light switch that you flick, and now all of a sudden you've got 15% certified, and you've got all of this amazing technology that exists that's event-driven, and a single old Windows server that's going to go bye-bye real soon, I'm sure.
Absolutely.
But let me ask you this question. So I learned something recently about the organization that I did not know. So you think about your tech teams. Your tech teams are crunching away, doing the things that they do. Rick, what if I were to get in the Wayback Machine and go back a few years and say, Rick, what if I told you in the future your teams would take a week off to just innovate every cycle, every 7 weeks? Would you believe it?
I would not believe it. I wouldn't have even advocated for that.
And that's exactly what they do. And that's because of the proven innovation that has occurred over time, because there was a roadmap, there was a plan, and we were there helping to execute on that. But somebody came along with an idea and said, hey, in this one area, what if? And realized that the seed of what if, across all these folks who knew the business and knew the technology, what they could create. And that's exactly what you guys are doing now. Tell me about that.
So we take a lot of ideas from the team. So, and what Jeff's talking about is a few months ago, our technical program manager, Milena Nelson, came to me and said, hey, I think it would be a good idea if we gave everybody a week out of every milestone, and we do 6-week milestones, 1-week sprints, 6-week milestones, to just do whatever they want to do. And my initial reaction to that was, what are you talking about? But we decided as a team, right, to do a trial on that. And that's worked out really well. I think we've done it 3 or 4 times now.
Yep, 3 or 4 times.
And we've gotten a significant amount of value in trying, doing integrations, trying out new technology that we wouldn't have done before. Right. That's now pretty key to our platform moving forward.
And I think that's the power of an innovative leadership team. It's the power of what the technology can do, event-driven, loosely coupled. You can add capabilities really pretty easy into roadmaps. It's not the old monolithic world that you can't shift away from. And that's just one of the tangential benefits that you see in this type of transformation. Your businesses are probably not all in the water life cycle of things. But wherever they are, I mean, it's this marriage between the intersection between folks who know the business and are brilliant at what they do and giving them the right tool set that has that level of flexibility baked into it. You mentioned partnership, and I do want to call on that because you called a piece of it out. We've been working with them for a number of years now, and as Rick was just talking about, that partnership has evolved. And what I wanted to encourage you guys with today also is don't go it alone. There are partners who have been around the corner you're trying to go around, across the next horizon, and they can help. And we see a lot of companies who really get very, they're very cautious to make that move. They think, oh, I'm getting into this marriage of this consulting company, and here they're going to come along, and what if it doesn't work out? We have to realize that the very nature of that relationship can and should change because you as an organization have to change. If you're going to adopt this technology in a way that is meaningful in the way that it is meant to be adopted, your organization really has to change in your approach to technology. One very specific example of that, I don't know where you guys are in your journeys, but let's think about if you're very far along. Think about the ones where you came from maybe, where your IT team sat here and your security team sat over there, and maybe legal was over there, compliance was over there, finance was over there. And if you know the DevOps world, you know that all of that has come together. In a world like this, you need to be working in teams where everyone is working in concert. The lawyers, or the compliance, the risk folks, and the security teams should be welcome in the team with the developers who are creating those bits of code all along the way. So as your organization makes those changes, your relationship with your partners really should change. And I think the example that we have here in our relationship over the past several years is really testament to that. And the fact that we really came in to teach you guys how to fish. And then, not to make a bad fish fry joke or something, but then to come along and just help augment and help you, see what around the next bit of the possible might be. Yeah. Well, we have a case study here I think we're going to talk about real quick.
Yeah, I did want to just talk about one more case study just to really drive the point home, just in terms of the impact and the scale we can achieve with this, right? One of our customers in the UK, which I think is actually the largest water utility in the UK, is Anglian Water. They serve about 2.6 million households, which I think equates to about 10 million people in the UK. And they operate 143 water treatment plants. So a few months ago, we launched our ML solution for modeling a water treatment plant in one of their plants. And that solution has over 100 nodes in it, so that it's actually a graph of 100 models. We use an ML ops platform that we developed, again, together with Annika, built on top of AWS SageMaker to do that. And just in this first few months, we've saved, and you can read this on their website. They've published an article on this on Anglian's website. We've saved them 154,000 pounds, just in things that they've learned about their system, where things are leaking, where infrastructure is bad, where they've got to go actually repair and upgrade things. That's even before we get to further optimizing those systems for reducing energy use, for reducing chemical dosing of that treated water. 154,000 pounds. Now, that's one plant. If you multiply that by 143, that's a pretty big number just to start with. I think it's around 22 million pounds.
Wow.
And that's just to get started. And so you can see why Anglian has taken such a big interest in this, and why this has such really huge possibilities for the future safety of our water resources.
Amazing. So thank you very much for your time. Gentlemen, thank you for being customers, and thanks for sharing your story. Thank you. All right.